So gated recurrent unit, or in short GRU, right? So GRUs are inspired from LSTM. They are quite similar to LSTM. This is the GRU unit. That is how GRU looks like. So if we see LSTM and GRU, they are quite similar. If I show you LSTM, so this is LSTM, right, which we have already discussed in previous video. So this GRU is the simpler version of LSTM. It is simple because it has, if you look at the equations, here we have only 4 equations in GRU, and in case of LSTM, if you see here, we have 6 equations here, right? So also, if you look at the internal structure, we have only 2 gates here in GRU, whereas we had 3 gates in LSTM. So that's I mean that means GRU is simpler than LSTM. So what are the advantages of simpler? We'll see, right? So here, if you see, in case of GRU, so just so in case of GRU, if you look at, we have only 2 inputs here. This is the first input, that is the ht minus 1 coming from uh, previous time step, and this is the xt, which is input to this time step, this unit. So now there are only 2 units. We don't have cell state. We are not maintaining cell state here. Only 2 inputs coming, right? And we are getting only one output ht, right? Whereas in LSTM we're getting these 2 outputs, this one and this one. Here we are getting only one output ht, right? So the other thing is, if we look at, we have only 2 gates here. This is the first gate and this is the second gate, right? So this first gate, this is called as reset gate, right? And this is called as update gate. So this reset gate, because we and if you look, this is this this structure is there, which was there in LSTM, and this allows us how much you should pass from previous state to next state. We have discussed in LSTM. This allows this short circuiting. We can short circuit, right? That means we can pass the input from previous state as it is to this state, output of this state, input of previous state as output of this state. So this allows us to, this helps us to maintain the long-term dependency in in uh, uh, in the recurrent neural network, right? So which was the problem of basic recurrent neural network. So that can be handled, long-term dependency can be handled by this short circuiting, right, which is similar to LSTM, right? Okay. So so these uh, so there are 2 gates. The first gate is reset gate. Why it is reset gate? Because if you see here, we have seen this was pointwise multiplication and this is pointwise addition, right? So this pointwise multiplication here allows us how much I should pass from the previous state to the next state, how much I should pass from the previous state to the next state, that we have seen, right? And this is update gate, right? This is update. That means how much we should update, because we have plus here, how much we should add to this to the output of this state from previous state, right? So so this that's why this is called as update gate and this is called as reset gate. That means reset gate allows us how much we should reset from previous state to next state, and this update allows us, this is reset and this is update. Update allows us, this plus allows us to add to the output, uh, how much we should add from the input to the output, right? Okay. So now there is one thing which was not there in LSTM. That was this one minus, right? This one minus allows us to subtract whatever is coming from here. Whatever is coming from here, right? We can subtract that from one, right? So if you see, this is one minus ZT, right? So we are doing 1 minus zt. Whatever is coming from here, that we can subtract from 1. This is 1 minus, that is again pointwise, right? So now if this zt is a vector, then we are creating a vector of 1s here, like this, 1, 1, 1, right? So we are creating a vector of 1, and from that we are subtracting this zt. So 1 minus, we are doing that 1 minus. Oh, so this minus whatever, if zt is a vector, we are subtracting that. Okay. Now, so the advantages of LSTM are, it is simpler than, sorry, advantages of GRU, it is simpler than LSTM, right? Then it is easy or faster to train. Why it is faster to train? Because you see here, there are less equations. There are less equations compared to the LSTM. In LSTM we had 6 equations. Here we have only 4 equations. So that means it is faster to train. Less equations, faster training, right? And number 3 is it is as powerful as LSTM. It is as powerful as LSTM, right? And these GRUs are being used, more than LSTM in recent days, right? Because it is faster to train, as powerful as LSTM, and it is simpler than LSTM, right? So these are some advantages of GRU over LSTM. Now, LSTMs are also still used. There is no clear winner between LSTM and GRU. In some applications, GRU is faster, and in some applications, LSTM may be faster. But in recent days, GRUs are being used widely because of their simplicity and powerfulness. So that is all about GRU.